So what I'd like to do is go through a presentation now with you on efficiency and the GCSE efficiency equation and potential calculations that you might have to do. The first thing to remember is the law of conservation of energy, and that states energy cannot be created or destroyed, only transferred, stored or dissipated. So transferred from one of our energy stores to another, stored, it stays in that energy store, or dissipated, goes into the environment as thermal energy. What this means for our equation is that the energy input must equal the energy output. So on to a question, but just first of all looking at the efficiency equation. Efficiency is useful energy output divided by the total energy input. So a question. An LED converts 25 watts of electrical energy into light energy. It wastes 20 joules every second. What is its efficiency? And I'll just pause for a second. You can pause the video here and have a go at doing the question. It's out of 4 marks and see how many of the 4 marks that you get. Okay, so going over the answer then. First of all, we need to work out what this means. 25 watts is 25 joules every second. It converts it into light energy. The useful energy would be light. It's always worth trying to work out what the machine's supposed to do. So if it was a car, the useful energy would be kinetic energy to move you from one place to another. It wastes 20 joules every second. What's its efficiency? So we're told how much it wastes every second. That 20 joules every second is actually 20 watts every second is wasted. But we need the useful energy. So let's have a look then. How do we get that? So useful is going to equal the total input minus the waste output. So that will be 25 minus 20, which equals 5 joules every second. Now we can put that into our equation, but we write down the equation first, because it may well not be given in the test. So it's always worth writing the equation out so that you'll get a mark for it if it's available. 5 divided by 25. This is called substitution. You're substituting the numbers in the correct place, and then you work out your answer. So it could be as a percentage. We can multiply by 100 up here if we want to get a percentage. Not that it matters. You can always write it as a fraction, and it's just as valid, unless of course you're asked for a percentage. So what could the marks be here? Well, I said originally there were 4 marks available. So it would be 1 mark for working out the useful energy. Could be 1 mark available for writing the equation. 1 mark for the correct substitution. Or 1 mark for the correct answer, the numerical answer. So there's only 1 mark for that available. If you only wrote that down, it's very possible that you would get all the marks. However, if you made 1 mistake in your calculation, you might get 0. So if you made a mistake somewhere along the lines, here perhaps, and you had not got 5, you'd got 4 joules per second just because you were working really fast, and you didn't write anything else down, you'd have got the wrong final answer, but you may well have took all the correct steps to get to the wrong answer. You'd get no marks. However, if you've done the correct steps for your working out of the first part, you'd have an error carried forward, and you may still get some of the marks. Okay, I think that's all I've got to say about the efficiency and the efficiency equation for this presentation. Hope you found it useful.